How's it going, everyone? Ignore the pants behind me. They're just hanging there. Today's video, what we're gonna talk about is the NeetCode as a way to now developing is a sense of how can we recognize the patterns when it comes to use this particular tools, data structure and algorithm, as a way to solve them, as a way to solve real life problems. And that's the entire goal of this series of videos. See how can we apply this data structure and algorithm, data structure like array, stack, queues, list, hash map, tree, try, as a way to see how you, and also graph, as a way to see of how you can use this way of organized data to solve common particular problems, especially when it comes to deal with large number of inputs or elements. That's the entire reason of all of this. And once we are able to understand that, right now it'll make sense of, again, learning these techniques that we need to identify, or these patterns, as a way to, anytime we see these particular issues, we can now come up with this solution. So the idea here is that most of the time it all boils down is to how you can visualize the problem. And because the methodology here is 45 minutes, when the first 10 minutes I'm going to describe is what we have done so far, all the different problems that we have solved, what is the value proposition of each one of them, and what is the reflection as well. And lastly, 20 minutes as a way to solve that particular problem, which is in today's video is the valid Sudoku. We already have a pretty clear idea of what we need to do. Okay. And then if we weren't able to solve that particular problem, then we're gonna take now is the video solution as a way to recognize is the pattern. So here in this first section, which is the roadmap, okay, as a way to now how you can use arrays and hash, that is going to build your foundation. Wait, what? No, this is not. Wait, what? Wait, what? They unlocked me a lot of this? Wait, what? No, oh, I think they unlock a lot of this, but I just want to solve is the blind 50s 75. Exactly. That's right. Okay. Which means that now is a short list as a way to now see what is the different patterns that arise. Dynamic arrays has uses. Of course, this is getting limit attention here. Has implementation. Like that. And well, let's go to describe briefly the value proposition of each one of them, as well as the reflections. So here in this contain duplicates, we look at how we can check is giving a collection an array of elements, numbers, if there are duplicates in that collection. Pretty straightforward, pretty simple. We use now a hash or a table as a way to count each one of this number. And if that number already exists as we count them, then it means that this collection now contains duplicate, which is false. All right. The value proposition, you see how you can use now this data structure as a way to solve that particular problem. They contain duplicate. Luckily for us, we use is a hash set, which now allows you to store its unique values. We also can use this as a set or a hash as well. Then we look at valid anagram, which is now see how you can now work is not only with a hash, not only with collections of string, but also with collections of characters, right? And how we can, as a way to validate this anagram, we need to transform that to one data structure to another, and in this case is from one string or from a string to an array in the case of JavaScript, and then we now is provide, given the JavaScript feature that we can use in arrays collections like sort, where now sort is based on the Unicode 16 based on the UTF-16 Unicode, which is a table of how now it look up for characters as a way to now see if they are the same. So it has a huge UTF or Unicode character, where in there you have not only is Latin character but Cyrillic, kanjis, numbers, Arabic, the Arabic alphabet, and they now actually assign is a representation, or assign is a number to each one of them. So if those characters actually are the same in that position, it means that, well, they are the same. If not, well, you're going to return is something, hey, they are not the same. And the whole point of this valid anagram is a way to check if, given these two strings, okay, once you transform them into an array and sort them, okay, then you're going to compare each one of those characters of those two strings sorted, and if they are the same, all right, then it is a valid anagram. This is very straightforward, simple. The other is the two sum, and in the two sum, which is something that is highly used in a lot of code interview, because now the idea here is to identify what is the index, giving a collection of elements where now you have only unique solution, which is what is the index of those numbers whose when you add up sums, when you sums, it matches to the target value. So the idea here is to, as we now iterate through that, we're going to see if we already have in our hash map in this table. If we don't have them, let's going to add that. That comparison will be is giving is the difference between that number, the target, minus the, which is usually, or we want to get is the absolute value from that, okay? If we assume that all of this collection of numbers are integers, okay? So we want to get that, and then we want is to actually, based on that difference and the absolute value from that difference, we want to see if that actually exists, if that value exists in our hash. If that doesn't exist, that's going to add this value to our hash. And we're going to go to the next element and compare the difference of that element minus the target, get the value, the absolute value of that, and then see we already see if that value we already have then in our store or in our hash. If we don't, we're going to continue to do that until we find them, or we didn't. And when we find them, we see, hey, now this is the index, and now this is the index that we store in our count, in our hash as a value, and the current index, and we break the for loop. So this is also quite interesting as a way to see how you can apply is the arithmetic, which is the foundation of all of this, the arithmetic principle, as well as the yeah, the arithmetics, the arithmetic, uh, as well as the data structures. This group anagrams is more like how you can now organize this kind of anagrams. I'm not gonna dive deep too much here. The TLDR of this is pretty much like having a hash where you're gonna store as a keys all of the sorted words that actually are the same, giving this collection of values. Okay, and as you iterate, once you sort that, if that doesn't exist, then you're going to add that sorted value followed by the value or the anagrams, and then you're going to group all of these anagrams based on that. I think this is the quite most interesting. Okay, the top k frequency elements and encode and decode string followed by the product of an array except self is because these two ones, at least the top k frequent elements and the encode and decode string, it's seeing now how you can represent things, and this is now the way, or actually the vast majority of all of this, the problem solving. The problem solving skills is a way of how you can solve now this, how you can represent a particular problem and a solution with this data structure. So with the top k frequency elements, what we did is just to see, all right, now that we receive this collection of values, we want to see which one of them is the most k frequent, which is something useful. For example, you want to know what is the most frequent days per month that are raining, or you want to know is what are the most frequent, what is the most frequent buy and sell orders in the stock exchange. So for example, and that kind of thing, that is something very, very useful. And the idea here is that, well, you're going to get this collection of values, you're going to count the number of occurrences using a hash, and then you're going to use now an array to represent, a new array to represent with the length of this collection of values that we received. We're going to use is this new array that their index will represent is the number of occurrence, which means that if in your hash map you count is 1 6 times, it means that at the position 6 you're going to now put is the value 1 in this new array. So because we're now inserting is all of these elements here from in this particular order, then we want to know is the most frequent, and for that we reverse that. So one way to do that is by using the JavaScript function reverse, or you can start counting your elements from the end of that. But I think in JavaScript it'll be much more easy to reverse that and then split that or slice this array per the values there. Per the k most frequent, you want to get that subset of that array. And here in the encode and decode is pretty much the top k frequency, but in here we want to work is not only with collections of number, but here we're going to work is with collections of characters. Okay, and how by encoding or adding some information to our stream, and then we times to decode that, we now know the information that we put in this string. So for example, when we encode that, we're going to put is now the length of that word followed by a separator that indicates that when the separator begins, now is when we have the word. Okay, and then we're going to append that with the next value of our or the next length of our the next word, followed by the separator, and the word, and so on and so forth. And when we want to extract that or decode that, how by using is now pointers as a way to now extract this data that we need to, all right, is the way of how we can actually get that. So this is starting to see how now you can start to work is with representations, pointers, and as a way to now move from one to another. This product of our array except self is something that is quite interesting because now we're working is with the arithmetic or with the prefix and the suffix or the postfix as a way to see how you can now calculate each one of those elements in one round, you and putting all of these values or putting is the value calculator in each one of those slots in your array, okay, and also with the postfix. And I think this is more like a mathematical hack here. But in today's video, we're going to take a look now at the valid Sudoku. And we have some couple ideas of how we can solve this, you know. Yeah, we'll have some couple ideas on how we can solve this. Stone game. Okay. Again, what we care about is this one. This is valid Sudoku. So the idea here is that we can represent now is this using a set as a way to now iterate through all of this row. If in a particular row, again, the validating thing is that we're gonna see if we already have in the row no duplicates, and in the column without duplicate, as well as that each one of these cells we're gonna get is now is no duplicate. So how can we do that? For the row, it's pretty simple. For the column, it's pretty simple as well. We can iterate through that, all right? But the thing is, the thing that's tricky is when each of 3 times 3. So because now we can is represents here what is the value at this position by saying is that, hey, by using is a hash or a set, we're now in the position 0, 0. We can now is represent is this different boxes here as a grid of 3 times 3, right? So where this first element, first box, it'll be 0, 0. The next one will be is 0, 1. The next one will be is 0, 2. Yes. No, the first will be is 0, 0. The next one will be is 1, 0. Okay, because it's row and column. The next one will be is 2, 0. And if we want to see if we get now this particular value here like this, we going to store now inside of that because here we're representing is these values. Okay. Okay. So by doing is this. I didn't quite follow this. The valid Sudoku here.
Hey everyone, welcome back and let's write some more NeetCode today. So today let's solve the problem valid. So roughly this is the memory complexity as well. So we want to represent each of these 3x3 grids with a hash set, but how do we know if we're at any particular value, right? Like I have labeled the indices, right? This is going to represent what row, this is going to represent which column. How do we know if any particular value such as 1, 1 happens to be in this 3x3 grid, whereas a different cell such as 4, 4 happens to be in this 3x3 grid? How can we differentiate them? Notice how each of these 3x3 subsquares happens to be 3x3, right? So one way is to basically make it so that we can have an index, right? So maybe 0 represents this row of the three different squares, right? And a 1 represents this row of 3 squares, and a 2 represents a row of this, right?
Exactly. So far so good.
And similarly for the columns, right? A 0 over here represents this column, a 1 over here represents this column, and a 2 over here represents this column. Then if we had two indices, right? If we can somehow take 4, 4 and convert it to 1, 1, then...
Okay, exactly. As we iterate that, and as we,
we know it goes inside this subsquare, right? So basically we have 9 different subsquares. We're going to have indices to represent them, right? A 1, 1 means that this is the subsquare that we're talking about, right? This 1. And the way the math is going to work out is since each of these is 3x3, we can just take the actual index, such as 4. Let's say we were given 4, 4, right? This is the square we're talking about. We can take 4, which is the row, divide it by 3, integer division.
Integer division. So once you do that, 4 by 3, it means that it represents is that
division, right? We're talking about integer division. 4 divided by 3 is going to give us a 1. Similarly, we do the same thing with the column, right? 4 divided by 3 is going to give us a 1.
And in our case, it's divided by 3 because we got is now 3 by 3 elements, because this is not the representation of this. And what we're doing here is that by now is transforming this representation from one to another. We need to find a way of how. First, we know how we can represent this grid, okay? But we also need to know is how we can identify or transform that particular index or that particular position into our representations. So for example, if we are now in the 4 column and in the 4 rows, in the 4 column and in the 4 rows, if we divide that by 3, and you might wonder why 3, because this is the representation of our grid, okay, which means that they must fall into this box.
Right, so if we take the actual coordinates for 4, divide the coordinates integer division by 3, then we get the index for the row column.
Exactly. So once we divide by 3, so for example, if you divide by 4, it means that is, so those square must be 4 by 4. That's the reason why we are dividing by 3. So is that increase? Again, this is a fixed solution for this.
It basically identifies which square this is a part of. Now let's just check that the edge cases work out. Let's try 8, 8, right? This is the boundary.
Exactly. If we try to the edge count, in this case, it's like the 8 and 8, okay? And if we want to identify to where that actually match, if we divide that 8 times 3 as a way to now know what is the integer that it represents, Okay, 8 times 3, this division. What division, what does it mean? Is that how many part 3 enters into that number? How many parts that divisor enters into that? In this case is 2, which means that this is now the representation, and that's quite interesting how we can use this division as a way to represent something. That's one of the pretty fucked up of all of this. Jesus, how can we use now not only division? Oh my God, it's now we're talking about is arithmetic, bro. Oh my fucking God, it's all about representation, man. Because initially we were talking about is how can we now is, and when I say initially is with the duplicate, right? Or for the k most frequent. And in that k most frequent, we look at how can we represent these ordered structures to solve a particular problem. And here with our valid Sudoku, we're saying is that how we can is represent now is this division, okay, as a way to now give us a number, and that number will represent now is the subset or this square in our Sudoku. Oh my God. Oh, it's this relationship, but it's based on representations. I think mathematics is something powerful and beautiful, and it is pretty fucked up that these people actually come up with this kind of idea. You need to have some drugs, bro. I mean, I mean, well, you need to have some drugs or no distractions, no woman in your life. You know, only time to actually think in that time, in that kind of thing. And I get it why the mathematic, the Pythagoras, one of the Pythagorean Pythagoreans, Pythagoreans. Uh, and I get it why the Pythagorean man. Yeah, of course, I know why they becomes like that. Jesus freaking Christ. Pythagorean, 6th century before Christ, based on and around the teaching of belief held by Pythagoras and his follower Pythagoreans. Pythagoras established the first Pythagorean community in the ancient Greek colony of Croton in modern Calabria. Circa early Pythagorean community spread through Magna Graecia. Already during Pythagorean's life, Pythagoras' life, it is likely that the distinction between the acousmatico, those who listen, oh, acousmatico, those who listen, who is conventionally regarded as more concerned with religions and ritual elements, and associated with the oral tradition, and the the distinction between the acousmaticoi, those who listen, who is conventionally regarded as more concerned with religions and ritual elements, and associated with oral tradition, and mathematicoi, those who love science, existed. Those who listens and those who love, or with things that can be, not those who love science, because it's not about those who love science, because mathematic is what one gets to know, and it's different. The ancient biographers of Pythagoras, Lambicus was a Syrian Neoplatonic philosopher. Syrian, holy shit. Syrian Neoplatonic philosopher. He determined a direction later taken the Neoplatonism. Propedeuticus is important for the study of the suffix because it preserves about 10 pages on otherwise unknown suffix known as the anonymous lambici. During the reign of Constantine the Great, Constantine. Proclus. In Nicomachi Introduction to Arithmetic, bro. We were talking about here this shit, bro. Nicomachi's theorem. We were talking exactly about. This is what we're talking. It's representations. It's representations, my friend. Plateau left. Why did they paint like that? anyway, but as you can see here, is that it's like this mathematicoi y acousmaticoi. The ancient biography of Pythagoras, Lambicus, and his master Porphyry seems to make the distinction of the two as the beginner and advancer. As the Pythagorean Cenobite practiced an esoteric path, like the mystery school, of antique, the adherents acousmaticoi follow initiation become as the Pythagorean Cenobites practice an esoteric path like the mystery school of antiquity, the adherents acousmaticoi following initiation became mathematicoi. It is wrong to say that the Pythagoreans were superseded by the Cynics in the 4th century, but it seems to be distinction mark of the Cynics to disregard the hierarchy and protocol. Ways of initiatory proceeding significant for the Pythagorean community. Subsequently, did the Greek philosophy tradition became more diverse. The Platonic Academy was arguably a Pythagorean Cenobitic institution. What does it mean, Cenobitic, bro? Cenobitic. Monastic. That stressed community life. Often in the West, the community belongs to a religious order, and the life of the Cenobitic monk is regulated by the religious rule, a collection of precepts, the older style of monasticism, to live as a hermit, and is called to live as an hermit. A third form of monasticism found primarily in Eastern Christianity in the Skete. The English word cenobit or cenobitic are derived via Latin from the Greek word koinos, common, and bios, life. The adjective can also be cenobiac in, I think this is Greek or Russian, koinoviakos, or cenobit, obsolete, A group of monks living in a community is often referred to as cenobium. Cenobitic monastic appears in several religious traditions, though most commonly in Buddhism and Christianity. The word cenobite was initially applied to the followers of the Pythagoras in Crotone, Italy, who found a commune not just for philosophical study but also for the amicable sharing of the worldly goods. In 1st century, Judaic monks describe a Jewish ascetic community of men and women on the shore of Lake Mareotis, which he called therapeutic. De vita contemplativa. To the Jewish philosopher, Members of the community live apart from one another during 6 days of the week, studying the Hebrew Bible during the daytime and eating during the evening. Whereafter on the Sabbath they hope to dream vision informed by their study. Members of the community compose book of Midrash. An allegoric midrash is an expensive Jewish biblical exegesis using as a rabbinic mode of interpretation prominent. An allegoric method of interpreting scripture. Only on Sabbath would the therapeutic meet, share their learning, eat common, albeit simple, meal of bread and spring water, and listen to a lecture on the Torah, given by one of the venerable members of the community. Even 70 Sabbath or High Sabbath was accorded a festival of learning and singing, which climaxed in an egalitarian dance. The 3rd century Christian writer Eusebius of Caesarea, in his ecclesiastic history, identifies philotherapeutes as the first Christian monks, identifying their renunciation of property, chastity, fasting, and solitary life with the cenobitic ideal of the Christian monk. Christian monastic. In Saint Pachomius, Melitians and Manichaeans, later Cenobites communities. Oh my God. So this is something that is inherited by them. Was a Greek Syro-Palestinian historian of Christianity, exegete, and Christian polemicist. He became the bishop of Caesarea Maritima in the Roman province of Syria, Palestine. This fraction here. The onomasticon. Eusebius of Caesarea. Eusebius of Caesarea. Eusebius of Caesarea. So all of this come Cenobitic. Oh my God. Pertain to a life in religious community. Cenobitic. In Spanish? Cenobítico. This is the first time that I hear about this word. Cenobite. But these were people that were dedicating their life to that. The Platonic Academy was arguably a Pythagorean Cenobitic institution outside the city walls of Athens in the 4th century before Christ, as a sacred grove dedicated to Athens, Academos. The academy, the sacred grove of Academos, may have existed, as the contemporary seems have to believe, since the Bronze Age, even pre-existing the Trojan War. Yet according to Plutarch, it was the Athenian strategos, the general, Cimon Mygildau, who converted this waterless and arid spot into a well-watered grove, which he provided with clear running tracks and shady walks. Plato, less known as Aristocles, lived among hundreds years later, circa 426 and 348 BC. On the other hand, it seems likely that this was a part of the rebuilding of the Athens led by Cimon Mygildau and Themistocles, following the Achaemenid destruction of Athens in 1480 and 1479 before Christ. The Second Persian War. First phase, Xerxes. Second phase, Mardonius. Recovery of the city. Themistoclean Wall. Athenians rebuilding their city under the direction of Themistocles. Burning of the palace of Persepolis by Alexander the Great. Modern archaeology excavations. Ramping Rider. Okay. It's because now, oh my God, it's because Themistocles was the one who created this era of abundance. A general, a strategos. Themistocles was an Athenian politician and general. He was one of the new breed of non-aristocratic politicians who rose to prominence in early years of the Athenian democracy. As a politician, Themistocles was a populist, having the support of lower class Athenians and generally being at odds with the Athenian nobility. Elected archon or ruler. In 419 BC, he was convinced the polis to increase the naval powers of Athens, a recurring theme in his political career. During the first Persian invasion of Greece, he fought of the Battle of Marathon, and may have been one of the 10 Athenian strategos generals in that battle. In the years after Marathon and in the run-up the second Persian invasion, 1480, 479, Themistocles became the most prominent politician in Athens. He continued to advocate for a strong Athenian navy, and in 483 he persuaded the Athenians to build a fleet of 300 triremes. This proved crucial in the forthcoming conflict with Persia. During the second invasion, he commanded the Greek allied navy at the Battle of the Artemisus and Salamis in 480 BC. Due to his subterfuge, the Allies successfully lured the Persian fleet into the streams of Salamis, and the decisive Greek victory there was the turning point of the war. The invasion was conclusively repulsed the following year after the Persian defeat at the land battle of Plataea. It was the final land battle during the second Persian invasion of Greece. Holy shit. Macedonia, Piraeus, Thessaly, Arcadia, Sparta, Argos, and Attica. Ionian revolt, Greek opponents of Persia, Greek neutral state, Persian Empire, Thrace and the Persian Empire. Persian Empire, Persian vassal state. Oh my god, vassal state. Ionian rebels, Mardonius, Xerxes Mardonius. Okay. Macedonia, Thessalia, Malis, Locris, Phocis, Botia. Okay. Oh my god. Okay. Good. And how all of this actually mix that. So the Pythagoreans Pythagorean established the first Pythagorean community in modern Calabria, 530. Of course, a couple years before or during that golden era, at the birth of Themistocles. And of course, we have time to think in that kind of thing. After the conflict ended, Themistocles continued his preeminence among Athenian politicians. However, he aroused the hostility of Sparta by ordering the refortification of Athens, a move counter to Spartan and Persian regional interests. Usurpers initiated a casus belli. His forebear, the detractor Amazing, and the democratic circle declared corrupted with a single authoritarian overseen to cleanse the adjunction of malignant authority. He was ostracized and went into the exile in Argos. Themistocles thus flew from South Greece from southern Greece. Alexander I of Macedon temporarily gave him sanctuary in Pydna before he traveled to Asia Minor, where he entered the service of the Persian king Axtares. Oh shit. Where he entered the service of the Persian king Artaxerxes. He was made governor of Magnesia and lived there for the rest of their life. God damn it, bro. God, what is that? Oh my God. Of Magnesia. Themistocles died in 459, probably of natural cause. His reputation was posthumously rehabilitated, and he was reestablished as a hero of the Athenian and indeed Greek cause. Themistocles can still reasonably be thought of as the man most instrumental in achieving the salvation of Greeks from the Persian threat, as Plutarch described him. His naval policy will have a lasting impact on Athenians as well, since maritime power became the cornerstone of the Athenian Empire and the golden age of Thucydides. Themistocles, as a man who exhibited the most indubitable signs of genius. Indeed, in this particular, he has a claim on our admiration quite extraordinary and unparalleled. Thucydides, rank strategos. Cypriot Grand Forces, Hellenic. Thucydides. Okay, Thucydides has been called the father of the school. Political realism. Political realism, which view the political behavior of individuals as the subsequent outcomes of relations between state and ultimately mediated by and construct upon fear and self-interest. His text is still studied at universities and military college worldwide. The Melian Dialogue is regarded as a seminal text of international relational theory, while his version of Pericles' funeral oration is widely studied by political theorists, historians, and students of the classics. More generally, Thucydides developed an understanding of human nature to explain behaviors in such crises as plague, massacres, and war. Holy moly. Realpolitik. And how the mathematics and politics, oh my god. You think you're Realpolitik. What the hell? It's because each one of them wants its portion. Exactly. Peloponnesian War from Thucydides. Tratado de Westfalia. Tratado de Utrecht. Congreso de Viena. Sistema Metternich. Sistema Bismarck. Tratado de Versalles. Realpolitik. The main objective of the state is to maximize the power accumulation. So you are letting is oh my god. This is quite fucked up. And this is part of the human nature. And it's to stop being this is time to grow up. This is time to okay. Oh my god. Oh nigga. Look at all of the things that we went through. It's just to describe how by counting or the arithmetic as a way to now see how you can add, subtract, multiply, and divide using this way of counting things, how we can now use that to represent stuff and using is data structures, way to organize our data as a way to solve common problems, especially problems related to scalability. Oh my god. Okay. So with all of the things that you already learned, right? Okay, and how now all of this, okay, uh, from the mathematics, or from the from the mathematics, or from the mathematicians, which is from the mathematicos or the Pythagoreans. Now one branch dedicated to be a cenotic, okay, cenobitic or monastic. So they focus their attention to that study of the mathematics, of the thing that they can learn. So they dedicate their life in a monastic way, in a cenobitic way, in a religious way. Oh my God. Okay. All right. And all of them is most of the time based on the Jewish tradition. So the Jews, you can trace back to some Jewish source, and they actually, because they were now a pursue civilization that actually inherit that knowledge of the world, especially of how you can now is counting things and measuring things, and then represent that to solve real life problems, especially scalable problems. So, for example, not only in terms of water, meat, but also another resources, and how they scaled that up. And when you combine that with the human nature, which is one of the things that Themistocles and actually help to, to see this, to now live a somehow life in order in Greece, to develop this real politics or the political realism, which is now focuses on how we as humans, uh, we were moved by fears and self-interest, or how now the individuals and the subsequent outcomes, or the individuals between now, so individuals and states, how they relate each other and construct upon between fear and self-interest. Oh my God. And how now this leads vastly to understand us a little bit more, which is now the thing, or this field of politics or decision making, uh, of politics and decision makings of realpolitik, which is focuses on the premise of the realpolitiks is to mm, mm, the premise of the realpolitik is, let me see if this actually, so the premise of the realpolitik is that it is based on balance of power, and how now all of this can share the same portion of power, and the states, uh, and how they can, oh my God, impact the choice on tactics. Some realistic maintain that a balance of power system is more stable than one that is dominant, that one with a dominant state, as an aggression is unprofitable when there is equilibrium of power between rival coalitions. Dominant Some realistic maintain that a balance of power system is more stable than one with a dominant state, as aggression is unprofitable when the equilibrium of power between rivals coalition. When threatened, state may seek safety either by balancing align with others against the prevailing threats, or vanguarding align themselves with the threatening power. Other aligned tactics include bucking, buck passing, or sometimes playing the blame game. Buck passing, buck passing. I think this is in Spanish. Is buck passing is chivo expiatoria. Buck passing for blaming. In chain game. Realists have a long debate how polarity the system impact the choice of tactics. However, it is generally agreed that in a bipolar system, each great power has no choice but to directly confront each other. Along with debates between realism about the prevalence of balancing in allies pattern. Other schools of international relationships, such as constructivism, are also critical of balance of power theory, disputing core realistic assumptions regarding of the international system and behavior of a state. Oh my god, bro. Historical evidence against balance of power theory. The balance of power scarcely exists anywhere as a conscious principle of international politics between 500, 1500. Evoking example of ancient China's and Roman civilization, Quincy right added. Balance of power systems have in the past tended through the process of conquest or of lesser state by greater state towards reduction in the number of states involved and towards less frequent but more devastating war. Until eventually a universal empire has been established through the conquest by all of those remain. To the balance of power theory too. Rousseau defined the theoretical limit how far balance of powers can alter. Will it be supposed that two of the three potentials might enter into an agreement to subdue the rest? Be it so. These three potentials, whoever they may be, will not possess half power of all Europe. In 2009, Stephen Wall observed within 2.5 centuries, only one potent possessed half the power of all the world, including Europe. In 2018, U.S. military expenditure, including supplement spreading, exceeds those of the rest of the world combined. Since 2000, the founder of neorealism, Kenneth Walt, American political scientist, confessed that the present condition of international politics is unnatural. Yeah, throughout history, yes. Clearly, something has changed. Wolfhoff, Little Kaufman undertook the above-mentioned historical study after they have coped with what they call the puzzle of the unipolar stability. Elsewhere, Richard Little wrote, even since the end of the Cold War created a potential anomaly, for the theory becomes the outcome has left the United States as the sole superpower in a unipolar world, a major puzzle for realists. Is the fact that unipolarity has not proven a global alarm to the rest to restore a balance of power. It is the fact that unipolarity has not provoked a global alarm to restore a balance of power. The same anomaly stretched 17 other experts of alliance. Today, at least, there is a little sign of serious effort to forge a meaningful anti-American alliance. Until right now. From the traditional perspective of balance of power theory, this situation is surely an anomaly. Power in the international system is about unbalanced, and it has ever been. Yet balancing tendencies are remarkably mild. It is possible to find it, but one has to squint. It's pretty hard to do it. No peer competitor has yet emerged more than a decade after the end of the US-Soviet bipolarity to balance against the United States contradictory realism, but it is quite old. Resistance has in fact appeared and may be growing, but it's remarkable that despite the sharp shift in the distribution of power, the other great power has not yet responded in a way anticipated by balance of power theory. Self-balancing, preponderance of powers. But this is all about starting is that oh, in any case, all of this was to look at the balanced powers and how now the Greco-Roman mysteries uh, so the whole point of looking at this is to see, at least for this moment, because I don't want to dive deep too much into this, is that how all of this start by with arithmetic and representations, man. Arithmetic and representations, my friend. So in this particular case, because now we can is now create is a set for a row, a set for our columns, and then they also look at now this square and how each one of those square we can think of this as a representation of as representations of a set, all right, which means is that in this position and in this position we're going to store now is this square, okay, by saying is now that we have is this matrix where we want is to where we now is to want to go through all of these items to the row and adding to the column to a set that store unique values, then the column, and then add each one of those elements as our set that store unique values. We also need to find a way of how can we represent each one of those elements inside of those blocks in our set as a way to store that. So by now saying something like represent is the 0 and 0, where now each one of those boxes here actually is one of this index 0, 1, and 2, followed by 0, 1, and 2 per row and per column. Okay, so now we want to know is which position belongs to this, which is now the 0, 0. We want to know if that actually is inside of our set. So inside of our set, we're going to store now is the value there. Is that it is? Are we going to store that value there?
What happens if we take 8 divided by 3 and 8 divided?
Because now that we have these representations here, as we iterate through each one of those elements, how do we know that this actually is each? Okay, how do we know that each boxes here, each square actually is what we are looking? Is because we're using is this set as a way to represent now this. Okay, but here in this set we go now is to okay, in this set we're going to store so in this set we're going to store now is this two-dimensional array. Okay, where now in the 0, 0 position you're going to have is all of these elements here. Okay, all of the elements here. In the 0, 1 we're going to store all of the elements here, and in the 0, 2 we're going to store all of the elements here, and then on the we're going to store this as a multi-dimensional array here.
Divided by 3, right? Well, then we get 2, 2, right? Integer division, we always round down 2, 2. That works out for us, right? Let's do a different edge case. Maybe we try this square, right, on the boundary. Does this identify 0, 0? Because that's what it should. Well, let's take the positions, the indices, 2, 2, divide them by 3, 2 divided by 3, 2 divided by 3. We round these down, so we get 0, 0. That does uniquely identify, or correctly identifies that it belongs to this 3 by 3 grid. So that's kind of how we're going to identify.
Yeah, this is a way of how you can now recognize that, hey, is this box belongs to this? Okay, this box, okay. Is this box belongs to this? And then let me check if now is the row and the column actually doesn't contain that.
When we go through every position, every cell in the entire Sudoku board, which of the 3 by 3 grids is it a part of, and then we can add them to that, right? So we're going to have a hash set where the key of the hash set is going to be a pair of values, the row column, not the actual row column, right? But the, when we convert it to the row column, basically row divided by 3 and column divided by 3. That's what the key of the hash map is going to be, and the value.
And the value will be is this set.
Is similarly going to be a hash set where we can tell, do we have
exactly, because if we identify as this, hey, that's right.
Have any duplicates in this 3 by 3 grid or not, right? Same for every single 3 by 3 grid. We're just checking, does it have any duplicates? If not, then we can continue. If it does have a duplicate, that means our Sudoku board is not valid, and then we would have to return false. But if it is valid, we're just going to continue. So we're basically going to go over the entire grid, right? Every single position in the entire grid. If we find any duplicates, we return false. If we don't, at the end, we can return true. So now we have enough information to actually write out the code. So let's do that. Okay, so now we can write the code. Like I mentioned, I'm going to be detecting
okay, so in this particular exercise, which was quite wild because that lead us is to understand is a little bit of the Pythagoreans, because now they were one of them that describe is this arithmetic, is this way of counting, is the art or the science right now of counting. Okay, and representations, and how by that, which is something that you can learn that as one of the things that they call with mathematics. So mathematic, according to etymology dictionary online, it says that Mathematicos means, from the Greek word, I'm reparaphrasing that, is what one gets to know, lo que uno llega a aprender. So the way of how you can learn that is by actually dedicating time, focus on that, understanding where all of these things are coming from. And most of the time is because it is something that it's a desire to learn, or is a most of the time it's a desire to learn, and also a desire to control, I will argue as well. So because of that, and how the Pythagoreans now, they split out into two branches. One of them goes for the more monastic or cenobitic lifestyle, which means that they dedicate their time and energy to study this mathematics, this thing that you can learn in as a religion. And now how the Jews at the first century, before after Christ, they create their own way of how they can mix that into their own culture, and that's one of the reasons they might actually is dominate somehow here, and it's because they now have this knowledge. This is just me playing the devil advocates, okay? This is just me playing the devil advocates, and how that uh, fields of study, or how now that a lot of people that dedicate their time to actually to think in terms of that, uh, the Pythagoreans, it was built based on the success and military triumph of people before them, um, that actually make the conditions to so you can now, or that the Pythagorean people actually can dedicate their times and energy daily to learn these things that you can learn, right? Uh, and how now, and the reason of describing these things is because now, when you are able to understand a little bit more the context of where you are, and especially is that how this golden age are created, is basically because it's a previous process of defense, wars that actually make the situations comfortable enough. You also can look at the meme like strong times or weak times make, or strong times make strong men, and strong men make good times, and good times makes weak men, and weak men make hard times, and hard times make strong men. You know, that feedback. Uh, this is just a way of how you can explain that, right? And how now the Pythagoreans actually is in joy of all of this. And when it comes to identify now the human nature, because we identify as the science, is the art of counting, is the art of how we can now how can we learn this thing, okay, or the thing that which you what one gets to know, is that now, with that, uh, how can we, by looking at our human nature and the realpolitik, which is something that previous strategos in ancient Greeks that actually make is the Pythagoreans' way of living in dedicated times and discovering all of these kind of things possible, is something that it is important to recognize in our life, which is that we are selfish, and we most of the time want to accumulate power in a forms of an individual or a state. And there's nothing wrong with that. I think you have only consequence based on that decision and how you wield your power. So, um, more than ever, I think this is something that is more important than ever. And there's several books out there, like 10 Law of Powers, that kind of thing, that it will decision making is crucial here. So once I know all of this, and because the time dedicated to learn how you can use this data structure and that kind of thing, it's just as a way of how by dedicating my time to do this, and when it comes to actually solve real life problems, uh, not only for banks or for other clients, it's like I know how can I tackle this particularly problem, and how a lot of people actually are looking for for men and women that can solve problems. This problem solving skills is something that they are looking for, but in the case of computer science, it comes from the mathematics, and you must know the mathematics, at least the fundamental of the mathematics, as well as their properties. For example, like arithmetic and fractions. Mm-hmm. And also logic. Mathematics, arithmetic, and logic. Again, these are tools that help you to now solve real life problems. But when it comes to solve your own problems, let's see how you can go with. That's a different. Again, the science help you to survive, but doesn't tell you how to live a life. You know what I mean? And that's where we are right now. So specifically, what we are actually right now here is by actually solving this value Sudoku and see how we can actually solve this. So because at the end of the day, we wanted to now use three sets. The one is to actually store is as we iterate through this collection of this matrix. Okay, as we iterate through all of these collections, now how can we is look for all of those elements and validate that we are when we add to validate that we don't have is any of these elements already stored. Okay, if we have them, so this is not a valid Sudoku. On the row, on the set, as well as on per square. And in this per square, we're gonna do is this. So because the representation here is that what are the number of boxes we have here in this Sudoku? Again, this is a man-made solution, and how you can use geometry here as a way to explain this. Once we use or once we can now identify, because here we know how can we identify is this position, right? 0 0, and then we have here is this 1 0, 2 0, 3 0, and we're starting it from 0. That's why we counting that by that. But how can we know that actually is a particular number is in this 3 by 3 boxes? Because now once we're able to represent is this, oh my god, is this boxes as our hash, or in this case as our key, when we say, hey, in this particular box, which let's going to represent this as 0 and 0, okay, and here we can represent is this as 1, and here as 2, similar for 1 and 2 per column and per rows. Okay, how by doing that, and because we want us to keep track is the store of this, once we say is, hey, is this actually belongs to this box, you may wonder how you can now say that this first element belongs to this box using this representation. So if you divide that 0 by 3, which is the first box here, okay, in that position, you say, hey, now this actually is on the 3 by 3. So if you do this, which means that now this is at the 3, but we need to divide that by 3. So now that we say, hey, is this element that is here, which is on the row of, which is at the row of 0 to 2, and when we divide that by 0, 1, 2, all right, is this actually where this belongs to? You know, hey, we divide this by 3 as a way to identify where this it fit. Where you gonna put this element here? So in this case, if you divide is this 2 and 2 by 3, it will give you 0, which means that at this position, this fits here. Holy moly. And we're gonna do the same for that at this position, which is now 4 and 0. Okay, so you divide now that 0 divided by 3 and 4 by 3. This says, hey, now this belongs is to the row 0 and column 1. And this is what we're gonna use as our identifier here in our hash as a way to now store this data. Holy moly. So how can we now implement that in code? Oh my god. So is this. So you now go to define is a set. What we're going to store is our rows. You say unique, let's gonna say rows, okay, which is now a new set, which is a data structure from JavaScript, which is good. The other is a cons, this is row, new set, blah 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 blah. Counts rows and new set, blah 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 blah. Counts cold, which is now the columns, as a new set here. And here we want to store is now a hash. Okay. That it'll have is this, which is the square. You know, the 3 by 3. Where this will be is now a new map, okay, where our key will be is that representation. Our key will be is the position divide by the number of blocks, blocks in our square, which is 3, which will, once we divide this by 3, we know when we're going to fit this. And yep, holy shit, our key will be the position divided by the number of block, and the key and the value is a set. So now that we know where we're going to store, we're gonna say is for every element that we iterate through this, which is in our board, okay. Because at the end of the day we want to work is with the position of that. And as we iterate through this, which is an array, which is a two-dimensional array, okay. And now how JavaScript, how in arrays how arrays in JavaScript plays. Yeah, how arrays in JavaScript plays. Um, yeah, it's like how array in JavaScript. How array in JavaScript plays two type. Either is a tuple or an array. And objects play two roles in JavaScript. Either is a record or a dictionary. Okay. So because of that, here, what the? Here we want is to now. I'm gonna use this the old way of doing this. It's gonna define here as an index. We're gonna start from 0, and then iterate this. I'm not sure if we can get that index. Let me see if we can get that index here as a way to get myself familiar with this. A key value. This is an iterable. So no matter regardless the data structure implementation, we should be able to actually look at this. Say key and value. All right. I just want to console.log data. Wait, what? Oh, because you expect, okay. Yeah, because line 1 it's a rows new set, and then it's a new set. A function whose declared, okay, line 1. Okay, a function whose declared type neither defined must return a value. Okay, return true or return false, right? Let me run this. Oh, of course, because it's in lowercase. Silly me. JavaScript now is evaluating and say, hey, what the F is this? And here, I'm getting is the key and value. Is that right? Okay. Iterators. Iterators in JavaScript here. Iterators in JavaScript. So for example, oh, I get it. It's because it must be called entries. Yep. Because after all, multidimensional array must like that, and this is exactly how you get all of these values. At the 0 position, you got all of these elements, which is great. That's exactly what we want. At the next position, we got all of these elements, which is what we want. Exactly. So this is a way of how you can use now this iterator protocol. We can also use this the old way, which is writing is a for loop, which is where you have much more control of what's going on. But the idea of using this is as a way to delegate this underlying logic of how you can now iterate and access to the data, which is a task by in itself. So in this case, we're going to delegate that to that. So so yeah, exactly. Key value using now the entries, because after all, board is an array, multidimensional array. But if we want to use now the iterator protocol, we use is the dot entries, okay, which is a function that actually say, hey, now we're going to implement is this iterative logic as part of our syntax for of, and any time that you want an element here, I'm going to provide is an iterator protocol or an iterator object. That follow is the iterator protocol. Hey, this is the shape of this object, which contain is a next as a function inside of this object. It contains a next as a function, and inside of this next contain is now the value and is done. And when the done is true, it means that it reached to the end of that data structure. Okay, good. So with this, the console log, the key and the value, now that our key here, in this case, we're gonna call this index and call this I. Okay, and that position followed by the calls. Okay, because now we got is the calls like that. Now I want you to iterate is again, but in this case I want you to give me is the value. In this case, yeah, that's right. But in this case I want you to iterate is, since after all this is an iterable, I want you to now iterate but using is the iterable protocol, which means that we're gonna use is the for of syntax, and it's in here that that I want to get now is the value of that position, all right, which is the index, as well as the number, as well as the number here. So now if we do this, what we're gonna do is to actually is iterate through that value. So we're gonna get is the I and the calls, followed by the same here. In this case, I want you to now get me the G and the number, if that exists. Okay, we run this. Cannot find G. Cannot find G. Really? Is this not the G? Or the value in this case? Oh, because exactly exactly. Yep. Because the way it does by default is by saying, hey, I get out of this block. So by the time that I'm evaluating that, I don't have that. And if you get in this, first is evaluating is now the index in that column, all right, and then the index in the rows. Okay, we can say is index column, say index column, index row, as a way to identify is this. What the hell is this? Why the F? Okay. Come on. Exactly. Index row. Alright. So then we run this. We have much more descriptive our code here. And there you got it, right? So this is now the index of the column, followed by the values. And then this is the index row, okay, that position, and then the exactly the okay, the index row is 0 and the index row as the value is 5, the index row is 1 and the value is 3, the index row is 2 and the value is nothing, and that kind of thing, you know, and that makes a ton of sense. So what we're gonna do is this. Okay. Okay. So if the value at that position and at that index, right, which is here is using is now this is quite a little bit complicated. No, it's not complicated. It's because I don't understand it. I don't get it. That's quite different. So by doing is this, okay, we will now able to now that we have the position of them for the columns, all right, and the row. So we want to check if that doesn't exist. Exactly, if that at that position we wanted to check if at that position that doesn't exist.
Column divides. If we
but in my case, you know what? In this case, I'm gonna use this now. I'm gonna use this. That actually is quite hard to get it. So we got an index here. So we're to say 0, and we're going to iterate now is until the. So now we're going to iterate to 9 times 9. Okay. We can say is I until the I is less than 9. Okay. And I want you to now is after through increment that value, right? And also I want you to now iterate again here, but in this case it's on the row position, okay? And since of course we're going to iterate from the rows to that position, which is 0 to 1, 0 to 9, or less than 9 in this case, then I want you to now is increment that, right? The after through. So after you evaluate this code, I want you to now update this thing. So if the board of that position ing is equal to the symbol that we got here, I just want you to ignore that. Okay, so continue. All right, continue. All right. Yeah, to continue. All right. However, if the boards, I think exactly it's in singular here. However, if the board at the position ing, okay, I want to know is the value of this, which is, hey, at this position, all right, is the value of this position, because we're going to evaluate this either in a row and in our column. Hey, if the value of this position here in 0 0, hey, is the value in 0 0 exists in our row, okay, which is existing our rows. So if the value in this position if the value in this position does not exist, okay, yeah, if the value of this position, or we can say if the value of this position exists in our rows, okay, or because that's exactly what we're going to store here,
then we return false. Basically, this is our hash map.
But this is the hash map here, and if the value is in the rows,
Right, rows is our hash map. The key we're putting in is the current row that we're in. So this basically represents a hash set, as you can see up above, a hash set of all values that occur in this particular row number. So basically
in this particular row number. Exactly. Here we're saying is that, hey, is this value exists in our row, okay,
if this current number that we're at is already inside the current row, meaning we've already seen this value before in the current row that we're in, that means it's a duplicate, right? In which case we can return false. But that's not it. Basically, the exact same thing is going to be true if this value has already occurred in the same column before. So we're going to change this to columns at the current column that we're at. So
exactly, but this is this row is because here at that position, hey, is this value is in this, do we have now in set in JavaScript? Exactly, we only have this has. Is that value exists there?
So if this value has already occurred in the current column that we're in,
exactly, because the whole point of this is to say, hey, is this row or is this value, we need to check is exactly. But what happens is that we need to check if that, so because here we are storing is all of these values here. Is this value is at is this value at this exists? Okay, so is this value exists in our in our row, at this position, if this value exists in our row or in our column, okay, and as you can see, exactly, if this value exists in our row or in our column, okay, because what essentially here we're saying is this. Exactly, is this value in the row? So is this value in the row exists, and is this value on the column exists? And not only
we're in, that means we've in before. So how do we get the current square that we're in right now? Well, we know, and this will return a set, as you can see up above, of all the values that we have seen in the current square.
the row and the column. But it's in here you saying is that here or okay, or the square has is at that position the board ing, but again, okay, the board in that position I divide by 3 and G divide by 3, which is the representation exists.
Before. And if this value that we're at right now is a duplicate, that means it's already going to be in this hash set, in which case we can also return false. So this is basically our way of validating that this current Sudoku board.
Exactly. This is the way of how we can validate is that the Sudoku here is false. And then we need to update
board is valid. We continue and we basically update all 3 of our hash maps up above the saw and do the exact same thing. So this makes sure that our hash sets are updated.
Exactly. But at that column, we're going to add this value. And at that row, we're going to add this value. It's because it's that. And it's because it's that. And it's okay. All right. After all, this will be is okay. After all, this will be is a map that is going to store unique values as a set. Okay. Both of them has a set. Okay, if this column at that position has that, then you got it. Now when it comes to actually update that, what we're gonna do is this way, which is the key here. We're gonna store this at the index and we're gonna add that value there. The key will have, so exactly is at the key position exactly. It's because the row set as the key, or in this case, yeah, the row at the key will be is the row exactly will be is the row, which is the first this is the column, and then this is the row. Okay, the column and the row index. Okay, if this actually is on the col and on the row, which is pretty much what we're gonna do here as a way to replace this, pretty much this one and pretty much this one here, as well as, but this will be is column, but what, no, this is row, row and row and row, and followed by the row here, which is now on your row. We're gonna have a map that is going to be is now is the row, and at that row I want you to now store is the value of that position, which is the column and row, right? Similar to the column set, we're gonna the column map here, what we're gonna store is this. Okay, what we're gonna store is our values here, like that. And if we already have that value, once we check okay, at this position, at the 0 position, you're gonna have this value, and the other position you're gonna have this value, and the other position, okay, this will store is all the rows. Okay, so here we're gonna have is the rows 0, this value, 0, and this value, 0, and this value, 0, and this value, 0, and this value, then 1 and this value, 1, and this value, 1, and this value, and then 2 and this value, and 2 and this value, and okay, holy moly. And then the calls with the bore of col and row. This is how you can update this, and when it comes to actually update the square, we're gonna set here and say our key will be is now the col divide by 3, but here we're gonna, okay, here we're gonna store is now a representation of this, a tuple here. We want to store now is a tuple here, which is just a fancy name to say that the col and rows divide 3, followed by, okay, the values at the bore, exactly the value of the bore on the cols and the row at that position. All right, hey, this is the col and row. If this is the 0 0, hey, this value will be here. If this is the 0 0, is this value here, and so on and so forth. God damn.
And
and then we return is if everything went well, we return is true for that. my bad. It is bore, col, and row. Oh, because there is additional like so. Goals has exactly. JavaScript say, who the F is this? I'm evaluating your code line after line, and now I'm seeing an additional parenthesis. I'm evaluating your code line after line. Now execute that and see exactly. After col is less than 1 and after row is less than 1, and now col must increment 1 and row must increment to 1, and that'll be all for that. After I evaluate all of your code line by line, now I'm going to execute this code for you, and then I see something like this. So bore is because it's because the way how I'm trying to access to this is like this. Is this one. Exactly. Is the way of how you can add to this multidimensional array. Followed by this, and there you got it. And here you got is you need to do this in this way. So this is now the way of how JavaScript actually access to the data here. Evaluate your code line by line. The same here. It couldn't find that data that I'm passing, couldn't have access to the data. Set will be here, and this time will be is like this when we want to actually add that column value at that position. When we run this, I think it's because but no, but I think it's here. This is something that is not going to work. It's because I need to check that as a tuple. As a tuple, I need to check that. Exactly, it's because it's this one. It's a map number and a set. Mhm. But the thing here is that now that'll be is that. Mm-hmm. It's because of this will be is a record. Okay, or a map of the number followed by a set of number, and the same for this. Mm-hmm.
We'll make sure to detect any duplicates when we get to the next iteration of the loops. So in this way, we're iterating over the entire board, and if we never detect any duplicates, then we can, outside of the loop, just return true. That means
Okay. Ah, bueno, mano, qué vaina es, ¿vale? ¿Dónde están las fotos, hijo? Mamá huevo, ¿y dónde mierda? ¿Dónde coño me estás guardando los screenshots, papi? ¿Dónde mierda me estás guardando los screenshots, mamá huevo? Mamá madre. ¿Dónde mierda me estás guardando los screenshots, papito, mi rey? ¿Dónde mierda me estás guardando los screenshots? Ay, pero ¿y por qué yo tengo que estar con esta vaina contigo, marisco? ¿Mm? Porque yo tengo que estar con esta vaina contigo, mano. ¿Y qué verga es? Ay, carajo. ¿Qué vaina, señor? Ay, vale. Pero ¿y dónde me lo estás guardando? ¿Dónde me los estás guardando, marisco? ¿Qué vaina es? Bueno, ¿y por qué no los veo? Bueno. ¿Y por qué no los veo, amigo? ¿Mm? ¿Por qué no los veo? Coño de la maldita madre, bro. Pero ¿por qué no los ve? Qué vaina, vale. Si es verdad, pues. Coño, ¿será que lo está? ¿Qué ni siquiera es aquí donde los tienes, marisco? Bueno, pero ¿qué vaina es? Ay, carajo, esa verga, marisco. En desktop, en document. Mamá huevo, basta, vale. Que, ay, carajo, coño, es su maldita madre con este pana, vale. Mano, ¿qué pasa, llave? ¿Qué pasa, llave? Coño, deja la ladilla, ¿vale? Verga, no joda. Diciendo document, no está. Mano, en download, pues. A verga, pero viste que eres mañoso. Aquí está, aquí está. Lo que pasa es que estoy ciego. Lo que pasa es que estoy ciego. Y le iba a formar un peo a este marico. Digo que no. ¿No? Ah, bueno, chama. No, ve, bloqueado así, claro. What? Bloqueado así de claro, mano. Bueno, chúpalo, bro. Una huevo, una boleta, mano. Correcto, pero esto es si tú lo tienes almacenado como esa. ¿Sí me entiendes? Exactly. It's because it has to be that way, bro. And unfortunately, this sets and a square is for very specific use case, man. It's for very specific use. When you want to do this now complicated stuff here, it's like actually doesn't work that way. Actually doesn't work as expected, man. Actually thing doesn't work as expected here, man. Actually thing doesn't work as expected here, so unfortunately we need to actually use is hash and that kind of thing and map. Yeah. Mhm. Well, that'll be all for this video. And the thing here is that especially when you're working with this, with especially when you're working with this valid Sudoku. Mm-hmm. Especially when you're working with this valid Sudoku here. Mm-hmm. And the reflections. Work with um, work with objects rather than maps. It is sometimes much more easy. Mm-hmm. Much more easy to manipulate. That's what happened. Okay. So yeah, that'll be all for this video. Take care. Bye bye.